In the past, I talked about a wonderful feature called View.Update and how it removes flickering with graphics and animation. I never went over how to use this feature properly, which is what I'm going to do today. So, View.Update, as I've said, removes flickering with animation. But it's not just as simple as calling View.Update like this. You need another feature set up here called Off-Screen Only. You can set this by typing View.set and then bracket and then quotation marks, off-screen only, and then anything else you want to set. So what this does is it makes an off-screen buffer that makes all the animation changes and saves it to this buffer. The problem with this is you don't see the changes, not until you call View.Update. So if I were to get rid of this, what this program does is it's essentially like a ball you move with the arrow keys. So I'm going to give an example. So I'm running the program and I'm pressing the arrow keys and it's doing absolutely nothing. Then when I press stop, it changes location. This proves that off-screen only prevents the changes in the animation from showing until View.Update is called. Now when I try and move it, it works. And it's pretty smooth as well. Now View.Update may sound really nice, but there is one drawback. Since it's constantly updating the entire view, it causes a big delay in time, which basically essentially means it slows the program down. So if you have Pong, let's say, and you use View.Update, it's going to take a long time to update everything on the screen. This effectively slows down your program, and there is a solution to that. There's another procedure called View.UpdateArea. It does the exact same thing, but it only updates a specified area. So essentially, I have a circle with the X radius and the Y radius as 10, and then it could change by 2. So I could type this, so it's the bare minimum. But there is a problem with this. It moves so much faster, but if you look very closely, it appears like half the shape is disappearing. You want to update past the view. So, if I were to make it 30, it works perfectly fine. Now another thing that you could do is you could just use View.Update, and instead of having a delay like I have right here, they will treat the View.Update as the delay because it takes so long. So let's see how that works. So I have View.UpdateArea acting like the delay, and me just slightly tapping the arrow keys sends it way out there. I mean a slight tap. Now let's get rid of this and replace it with View.Update. Let's see the difference. Look at the time difference. Look at how much slower it is. Now the problem with using View.Update as your delay is if you have a really fast computer, the View.Update will be much quicker, so the game will be quicker. But if you have a really slow computer, the View.Update will take longer, and your gameplay will be slower too. By using a delay and View.UpdateArea, you can effectively keep the same speed, no matter what computer you're using. The difference is View.Update is doing 1000 by 800 pixels, which will essentially be 800,000 pixels every time. Whereas View.UpdateArea does about a 60 by 60 pixel count. So let's do a calculation. Let's see how much faster it is. So 800,000 divided by 3,600, because that's essentially how much it is. It's over 200 times as fast. So this tells you how much time View.UpdateArea could save. So in conclusion, only use View.Update if you're going to make a giant full screen change. Otherwise, if you're doing a video game where slight things are changing, use View.UpdateArea. So thank you guys for watching this tutorial. If you liked, you can subscribe to my channel. This is Ogini Supreme, logging off.